so many ideas going on in this project, but it's just the start.
Good design is all about creating that moment of bliss.
This is really also the hospitality and the tourism of tomorrow.
This is what we want to show.
We have created something which blends into the environment, and the house itself is basically seamless.
Imagine you were able to just teletransport.
You are on your own island in the center of Amsterdam.
I think you have to go there to believe it.
I'm delighted to welcome RTA and Irving Smith to make the first presentation. They won the Higher Education and Research category for their Scion Innovation Hub in Rotorua, New Zealand. Welcome, and over to you.
Okay, welcome to New Zealand and welcome to Te Wharenui o Tudiata. I'm Richard Nash from RTA Studio, and I'm co-presenting with Jeremy Smith from Irving Smith Architects in the South Island of New Zealand. This is a timber structure building, and it's a government research institute for the forestry. Now, on the days just following COP26, there has never been a more important time on the planet for making low-carbon buildings. We know that the sea level is going to rise by 30 centimetres by 2060, and we already have 1.2 degrees of warming of the planet since the Industrial Revolution. So come and walk in our forest. This is a building that's going to do things differently with timber. This is us right down here in the bottom corner of the South Pacific. So when things come by boat, they really come by boat. And we don't have a lot of steel and concrete in this part of the world, so all building materials arrive this way. But what we do have a lot of is sustainably grown timber. So this project's about harnessing carbon rather than releasing it. This is where we are based, our building in the middle of the forestry growing region of the North Island of New Zealand, a place called Rotorua. And the research that's done here is forestry research and wood polymer science, and it's not just for our community, but it's global research going on here. When we arrived at this project, it was behind a high gated fence, and this was the underwhelming entrance of the whole campus. So we first addressed the master plan. The red arrow shows the backdoor entry that we just came through. So we decided to place the building public facing, to take it outside of the fence line, to face it towards the public and the large amount of tourists that come to this part of New Zealand. So it's a public-facing building outside of the fence line, and the entire ground floor is devoted to public activity. You arrive, straight ahead of you is the reception. There's an interactive display to educate the public about the science that goes on in the institution. And there's meeting rooms. There is a cafe, more importantly, where people can enjoy the building and just enjoy the environment. From here, you go through access control. The staff can go through access control to the science areas of the campus, both horizontally and vertically. So it's a 3-story building, and on the 2 levels above is where the live science happens. This is where the scientists come and workshop and join each other in the environment, which can be seen from the public area in the ground floor. So it's a high-tech facade. It has a double ventilated facade that preheats air in the winter and pre-cools it in the summer. And it also has a high-performance skin. Pattern making here has been informed by Indigenous artwork, but also, more importantly, it is about mitigating the solar gain and the glare within the building. And we've got different percentages of fritting across different aspects of the glass depending on which way they're facing the sun. So we invite you to come and take a walk through our forest, and Jeremy's going to take you through the central part of this talk.
Sure. Now we of course live on both sides of a plate boundary where the ground shifts at the same speed your fingernails grow. Heavyweight construction wasn't easy to hold on to in Napier in 1937, and it wasn't much better in Christchurch in 2010, 2011. Now, we had made timber structural buildings, even innovating low-cost damage avoidance design, but we were following convention. We were thinking big, as the name mass timber suggests. So when the New Zealand government's Timber Research Institute invited us to do this new building to their campus and to use more timber, please, we replied, the answer in anything sustainable isn't to use more, it's to use less. We should be making less mass timber structural buildings. So we questioned, why do timber buildings do the same 90-degree gymnastics as steel and concrete buildings when the strength of the tree follows the grain and is continuous? That affects the size. So we gave them a 3-story high timber structural diagrid with a continual load path. We removed the concrete slabs, but they are about 40% of the weight of the building and have to be held up in the air and braced. And between diagrids, we place a fuse to yield in an earthquake and then be replaced. And key to it all are these highly innovative timber structural dovetail connections, which allow the load to pass continuously through the node. We could make these with the limited tools already in New Zealand, no boats required, and they negate the costs and complexities and fire rating issues that come with the steel components at the junctions in timber structural buildings. Now, the diagrids are allowed to rack, which transfers the loads to the fuses and also means we can re-level the building after a seismic or geothermal event. And the effect on the size is extraordinary. So timber structure is usually about the same size as steel and concrete, or a little bit bigger. Say on the previous example, 500 millimeters square. Here, it's 300 by 90, less than a quarter the size. And of course, by being smaller, timber is easier to resource, to transport, to fabricate, to erect, and ultimately change. So we resolve the building in its corners and simplify the system down to have 6 bits. If we had 126 or even 26, we wouldn't be making this building in a small country like New Zealand. And you can see just how slender the timber work is as the building starts to grow. And as the double skin ventilating facade arrives, the building turns into a forest. And it behaves like a forest. The closer you get, the more you see. And inside, the light continually changes throughout the day as if under a canopy. So if we spin around during construction, you can see just how legibly the different bits fit together. Which means we can say to the community, come walk in our forest, come be part of the future, come see where timber can take us. So if we're a member of the public wandering around on the ground floor, you might be looking at displays, you might be at reception, you might just be at the cafe, or you're a scientist working in the collaborative spaces above. You're part of a community and you're embedded into our part of the world. You're part of a larger discussion about how we all work together to better participate with the environment. It's part of the welcome and the life of the building. It's what we call manakitanga. And of course, being small doesn't mean you can't get bigger, as we're looking at on other projects. But being small really importantly means that we can use more timber in more timber buildings rather than use more timber in selected timber buildings. Having less mass makes the process iterative and makes being carbon better achievable. Back to you, Rich.
Thanks, Jeremy. So I'm just going to wrap up just talking a little bit about the carbon metrics of the building. At the time of completion of construction, we had it evaluated and certified as embodied carbon zero, which of course means that the amount of carbon stored in the timber in the building equals the amount of carbon released from a small amount of steel and concrete and glass. We also had the whole of life analysis done, and we found that we were already meeting the target of that the RTA has set for 2030. It's a building of national significance. It was opened by our Prime Minister, and it took only 35 minutes for the New Zealand Forestry to grow the wood in this building. So hopefully this is a project where the innovation reaches out of this community, out of the region, out of New Zealand, and reaches out into the world. It's really a building of simple technology. It doesn't just apply to small countries at the bottom of the world, it's applicable to the whole planet, hot, cold, dry, wet, and it's a taxpayer-funded building, so it hasn't had an unlimited budget. This was built for a similar cost of conventional construction. So hopefully this leaves you with a taste of a prototype of a building, making low-carbon commercial buildings possible globally. Thank you very much.
Okay, that's great. Well, congratulations on winning your category. A lovely presentation. I'm going to invite questions and comments from the jurors. And Christina, if I may, I'll start with you.
Thank you, Paul. So early in the morning. It's a wonderful presentation, and I did like the story of the wood and following the grain and reducing the mass of the structure. I thought that was a very clever approach, and it certainly is going to make me think a lot harder about the projects that we are doing. So thank you for that. I think that there was an incredibly clear presentation on the structure and on the timber approach to this project. What I'd like to hear a little bit more about is the facade, and how was the choice and the design of the facade made, and how does that really correlate to the structure itself?
Yeah, thanks for that question, because it allows us to talk about the consultation that we had with the local Māori tribes that sort of had custodianship over this part of New Zealand, and so there was a lot of consultation with these people, and that led to the design of the facade in terms of the colours relating to not just the autumnal colours of the deciduous trees, but also the native evergreens. And it also is a little bit like a Māori cloak that's draped over as the metaphor. The three gateways you can see there represent the three tribes of the area, and a local artist was invited to design the patterning there, which has been digitally CNC milled onto those areas. That's the design part of it. The high performance side of it, I think I explained in the talk. It's essentially an aluminium curtain wall that's clipped back to the timber structure, and the two left-hand panels either side of the doorways are double facades with ventilated airflow systems to reduce load on the building services.
Well, okay, Kim, would you like to ask a question or make a comment?
Yeah, very much so. I have been to Rotorua, so I really love, and I really love New Zealand. So it's great to see a project from New Zealand and from Rotorua, beautiful area. I like your take on the timber structure and how to reduce the amount of timber in a very elegant and thoughtful way. I have also a question about the facade, in the way that the facade is very straight. You have this angled structure, but the facade is sort of more ordinary, and the same with the layout inside the building. Can you explain a little bit more about that?
So this is the first time this has been done, and we're a little country. There's 2 factories in New Zealand that can make one of these diagrids. Each time they make one, it takes the whole floor. So you know, we've really, in order to kind of do this kind of innovation, we've really simplified. That's how you if you live at the bottom of the world, you really simplify with what you have. And so that if we'd tried to do kind of an organic type of building, we would never have been able to make it.
No, I'm not talking about organic, but you have this angled structure. So you could have worked with a very straightforward but angled facade as well. So it played up to the structure. And the same with the inside.
Yes, I think the answer to that perhaps is that the building is the hero of the building is the interior, the interior structure, and we've tried to make the exterior hero of the building about the high performance glass facade. So the angles and the diamond grids are all inherent in the design of that fitting on the glass, and so we've just got a very simple orthogonal double glazed glass facade as a substrate to that. So there wasn't any sort of interference between the reading of the timber structure from the inside to the outside, particularly at night time like this, where you can actually sort of see through and see the timber structure.
Yeah, okay, thank you very much. Okay, Nuno Gonçalves Fontara.
Hi, hello. Do you hear me?
Yes.
Yes.
Okay, because I never know what's off mute or not. So, beautiful structure. I think the building is quite beautiful, and the way the structure is designed looks very interesting to me. I just have one question. So, when you talk about it, almost like an engineer. No, so everything is justified. Everything is done. There is nothing subjective about it. No, you try to make it as much more. But when you design the structure, it's not all engineering. You know, most of it. There's a lot of architectural decisions, aesthetical decisions that you are taking when you are designing that structure, right?
Could you just repeat that last bit that sort of cut out?
Sorry, I'm saying that all the presentation was made from a kind of a very kind of engineering point of view. You know, we are making a wood structure, etc. No, the looked like everything was. There was no other way to do it. No, that is the only way to do the structure. So I like the structure very much. I think it's very beautiful. But there are architectural decisions that you are taking it when you're doing the structure that are more aesthetical related.
Yeah, no, I think the answer to that is that we've set out, as Jeremy explained, a very sort of simple set of 6 parts, and every decision made beyond that in terms of architecture has been made with a similar sort of rigor. So the stairs you can see here have no column; they're cantilevering out. The ceilings have a hit and miss arrangement so that the services go through every second bay and then the timber's exposed. The ceiling of the building is the one expression of storytelling that goes on about this constellation of the stars, and it's mapped into the ceiling. The acoustic treatment in there follows a DNA patterning of the Pinus radiata timber, so there's some cultural and scientific references to the ceiling and so on. So, but the answer is that the rigorousness of the structure has delivered a rigor in terms of the architecture.
And that's kind of about the building being outward looking, and that the intent of the research in the building is to contribute to the community nationally, internationally, and the feel of the building is to be, anybody in the building can piece it together, can understand how it fits together, and then understand how it's doing something new. And so the idea of it being visible and being a very live space is important.
Thank you very much for that. Thank you for your presentation.
Can I just say one thing as we finished? We lost a bit of time. What was that?
Yeah, you can. 30 seconds.
One of the most interesting things about this building is that it has a very small timber size. It has a concrete perimeter beam foundation for geothermal, and it has a curtain wall glazing system. And it's still carbon neutral on day one. And that's really important as we're all looking to try and embed carbon. And that, that's a,
that's noted and understood. Congratulations on winning your category, and thank you for your presentation. We're staying in Australasia for our next project, which will be presented in about 2 minutes' time. Thank you very much indeed.
Thank you.
Thank you.
Thanks, guys.